Okay, so today we're going over conic sections. Okay, specifically we're doing the parabola. Okay, so first thing is that parabolas are used a lot. We use parabolas in everyday architecture. We use them a lot when we talk about projectiles, trajectory. So, like if you've taken physics, you already know that most ballistics, like rockets and things like that, they follow a parabolic arc. Okay, free fall, things like that. So we use it a lot. Now, the formal definition of a parabola is the set of all points in a plane where it's equidistant from a line called the directrix and a fixed point called the focus. So just like a circle is all the points that are equidistant from a center point, which we call that the radius, a parabola was originally looked at as this. It's the points where if I pick a line and this focus, if I take all the points that are equal distance from those two, I get the parabola. Now, what's really important is that means that this point right here, which we call the vertex, that means that this distance from the focus to the vertex and the vertex to this line called the directrix has to be equal. And we actually call that distance p. And we'll talk about p later when we talk about the equations. Okay? But that's going to come back and be really important. Now, the parabola itself is really important because, for instance, acoustics, or even the way radio waves work. Okay, so in a satellite dish, it's parabolic in shape. This right here is the focus point. So what happens is all of these come in, and no matter where they hit, they are going to bounce back up and hit directly into the focus. Okay, it's kind of the way it works, and it takes a large area, and you can have a very small signal, but you're going to focus all of that signal over that large area into one point. It's not any different than optics when we talk about exposure time. When you take a picture and you leave the shutter open for longer, it takes in more of the light, so the darker pictures become more visible. Okay, it's that same kind of idea. We're focusing all that light into that one area. Or in acoustics, when we talk about that focal point, when you're on stage, the sound leaves the stage. When you're on stage, it doesn't sound the same as it does to the audience. Okay, because they're in that kind of that focal area where it actually amplifies and moves it out towards them. Okay, that's why when they record things, they don't put the microphones and everything right there on the stage. They put them either on the person themselves, or they put, to record the whole thing, they put it out in the audience area. Okay, so let's start with the parabola that you're not used to. Let's start with the parabola that opens to the left or right. Okay, when we look at the parabola that opens to the right, that is our x equals y squared parabola. Okay, and when it opens to the left, that's negative x equals y squared. So just like it did with transformations, this negative right here reflects it, this time not over the x-axis, but reflects it over the y-axis. So if it's positive, then we're talking about a parabola that opens to the right. When it's negative, we're talking about a parabola that opens to the left. Now this is only when the parabola has its vertex at the origin. Of course, if it has other transformations, like our vertical and horizontal shift, that's this equation. Okay? Now in this one you see, of course, we've got our h and our k. Y is still with k, h is still with x. But here is our vertex of our parabola. This is our focus, and this line right here, that's our directrix. Notice that this is p equals 2. This distance from here to here is 2, just like this distance from here to here is also p, which is equal to 2. Okay? And that's something we're going to keep coming back to. P is that distance. Now this p is also this p that we talk about in our equation. So whatever p is in our equation, that's our distance from our vertex to our focus. Okay? And we use that a lot. All right. Now, there's some key characteristics. When a parabola opens to the right, P is the distance from the vertex to the focus or the directrix. The coordinates of the focus will always be h plus p, and the equation for the directrix is x equals h minus p. And the axis of symmetry, which is going to be y equals negative b over 2a. Now, this right here is when we have it opens to the left or right. Okay? Now, for my kids, this is my code for today. It's P4, R4, B0, L4. P4, R4, B0, L4. Okay? Now let's look at the parabola that opens up and down. So when we have a parabola that opens up, this is the one that we've been accustomed to. We've seen parabolas now, this will be the fourth time at least, because I know you've seen them once in Algebra 1, you saw them once in Algebra 2, we talked about them earlier this year in pre-cal, and now we're going over them again in Conics. Okay? Now we've gone over up and down parabolas all the time, it's the left and right that are a little bit different. But you should know this equation, y equals x squared. The difference is now that we have this 4p sitting in front, and that has to do with this whole directrix and focus, which we never dealt with before. Okay, so, but again, this is just our regular parabola. This is with the vertex being at the origin, and it looks like this. Okay, we're used to this. Now, of course, if this 4p is negative, then it's going to open down. Okay, the standard form of a parabola that opens up and has a vertex at hk is this, and it looks like this. Now, this doesn't really look like the equation that we've had before, but now, again, there's some characteristics that we need to know. Again, P is still the distance from the parabola vertex to the focus or the directrix. But now, since we're vertical parabola, opening up and down, my focus is now at H, and then it's K plus P, and our directrix is Y equals K minus P, and our axis of symmetry, of course, is a x equals number, x equals negative b over 2a. Which that should also look familiar because that's the first part of your quadratic formula, that negative b plus or minus the square root of the whole thing over 2a. That's that first part of it. Okay, but that's what we're going to be talking about with parabolas. So the only difference is now we got parabolas that open up to the right and to the left and up and down. Okay, and that's parabolas and conics.